well, let's go ahead and get started with our test review. We went over the quiz in here in detail, making sure students understood what was going on there. If you have any questions on your quiz, make sure you reach out to me if you're watching on YouTube. Get those questions answered, because the kinds of things you saw on the quiz are the kinds of things you're going to see on the test tomorrow. For now, though, I want to go over your homework, which kind of reviewed some of the older stuff we've done. We've been in Chapter 11 talking about probability and relative frequency. The test is going to cover sections 10.6 to 11.2. And so let's go back and review some of that 10.6, 10.7, maybe 10.8. I can't remember the section numbers exactly. Let's go back and review that material now as we look at our homework, page 493 in your textbooks. Page 493 in your textbooks, unit numbers 25 through 36. I know we kind of had a 3-day weekend, so some of you might have done this back on Friday. How many did this Friday? How many did it over the weekend? How many did it this morning, last minute? Just kidding. Hopefully not. How many of you, as you were doing, was like, it's been a little while since we've done this, and you had a little bit of that rust. It hadn't been that long, but anytime you have a skill that you don't use repeatedly, it's easy to start to forget. So that's why I want to make sure we take the time to review this so we're ready to go tomorrow. Really, truly, if you know your stuff, and if you feel it's not a hard test, just think through and do what you know to do. So picking up with number 25, this is as easy as plugging it into your calculator. Permutation of 31, take 5, gives us what, Kendall? 20,389,320. Good, 20,389,320. You need to know the formula. You don't have to use it, but you have to know the formula for a permutation. What is the formula for a permutation of n items taken r at a time? Audrey, do you remember? Close. Brandon? N minus r, factorial. And again, this exclamation point just means factorial. Really what it means is if the n is a 7, we would do 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. And if this were, say, a 2, we do 7 minus 2, which is 5 factorial in the bottom. 5 times 4 times 3 times 2 times 1. Cancel stuff away and so forth. Again, you don't have to use the formula, but you do have to know the formula for sake of testing purposes. 26, what's a permutation of 22 items taken 6 at a time? Michael?
53,721,360.
Great job. 53,721,360. Now, in number 27, we come to a combination. The formula changes. Again, not that that matters to us. We're using our calculators anyway. But what is the formula for a combination, Maddie? There we go. It's the same thing, but there's an extra r factorial in the bottom. What that does is it cuts down on the number of possibilities. So on a combination of 15 items take 7, Genesis, we get... Did not do that one yet. Abby?
6,435.
Good, 6,435. Is that what you got just now, Genesis? Mm-hmm. All right, let me come back to you and get number 28. A combination of 16 take 10? 8,008. How many got all 4 of those first ones correct? Now, remind me, what's the difference between a combination and a permutation? Abby?
In permutation, order does matter.
On a permutation, the order does matter. So taking red, then yellow is different than taking yellow and then red. If it matters, if it makes a difference, which I can't imagine why this would. Well, for instance, let's put it this way. Our school colors. What are our school colors, class? Blue and gold. Not gold and blue. Blue's the main color, right? Gold is the accent. Gold and blue would be gold is the main color with a blue accent. There is a bit of a difference there, I would say, right? So maybe in that case, order matters. But if the order doesn't matter, class, that's just a combination. But the key to either of those is you've got a group to choose from, and you're taking a certain number of that group, not taking necessarily the whole group. What if, though, I wanted to figure total possibilities, and instead of once it's gone, I could reuse a value? Then I wouldn't use a combination or a permutation. What would I do to find possibilities if you can reuse values, class? Yeah, just basic counting, which involves just multiplication. Yeah, just multiply if you can reuse values. Again, what's that little exclamation mark thingy, class? Factorial. Let's take a look at numbers 29 through 32 now, where we were expanding binomials. And again, hopefully you've got your cover sheet still with Pascal's triangle and nothing else written on it. If you didn't have Pascal's triangle, class, we know the triangle starts at the top with a 1, and then it goes to 1, 1, and we continue to just keep having 1s going down the sides in a triangle. But here in the middle class, we would put a 2, because we'd add the 2 1s. Here we put a 3, and then here we put. So if disaster strikes, and tomorrow you don't have your copy of Pascal's triangle, we don't have to freak out utterly and panic, right? And mind blow. Just make a new triangle real quick and hope that it doesn't go very deep. And usually it does. And here, for instance, if we look at 29 through 32 in your book, how big of a triangle would we need, class? Only down to the 5th row. So we only need one more row than what we've already got. So 1, 5. Right, so I mean, this is as far as we would need to go with the triangle anyway. All right, so for instance, on number 29, we got x negative 4 to the 5th power. I'll start by writing out what, Audrey?
1, 5, 10, 10.
Yeah, this row we just wrote. 1, 5, 10, 10, 5, 1, with some gaps between them, of course. Then I'm going to start filling in some of the other pieces and parts. I'm going to look, remember, to the first term, and I'm going to start it out, Brandon, as
x to the 4, x to the 4, x cubed, x squared, x.
There we go, just descend the x. Then we're going to look to our second term, not worrying about the sign yet, remember. The sign just makes things challenging. I don't want to think about the sign right now. I just want to focus on the 4. What do we do with the 4, Michael?
4, 16.
Well, hold on. Right here, 4?
No, 0.
Okay, so nothing here. So we start the 4 is gone, just like the end of the x is gone. Start the 4 is gone. But here you said we start with 4.
Then 16.
Which is 4 squared.
64.
Which is 4 cubed.
256.
Which is 4 to the 4th.
And 1024.
And there we go. And again, the calculator can help you obtaining those values. Then we're going to account for the sign at the very end. What do I do with the negative sign? Kendall? We're going to alternate, but you always start with a positive first term. Now, usually we'll leave it understood. We don't have to write it. We could. We don't have to. But the second term is where we're going to start a
Negative, positive, negative, positive.
And then it just comes down to doing what, Genesis?
Multiply.
Yeah, multiplying the values together. So here it's just an x to the 5th. Here, 5 times 4 class. So we get a negative 20x to the 4th, then 10 times 16. 160x cubed, then 64 times 10. 640x squared. Ooh, 256 times 5?
1207.
1280?
Yeah.
1280. 1280x, and then of course that's just a negative 1024. And how many have this answer for number 29? All right, other than the 1270 instead of 1280? Otherwise good?
No, I didn't do them. Do you want your homework back?
Yeah, I would. All right.
Here.
All right. Questions on these? All right, so now, Michael, again, nothing wrong with using the homework pass as long as you remember how to do this for the test tomorrow. That would be my only fear with the last homework assignment before a test using a pass on, but as long as you're good, all right. Questions from the rest of us? All right, let's take a look at the next one where we're raising an x plus y to the, we could just give the answer to this one, all right? There's no math involved at all on number 30. Maddie? There we go, x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th is correct. Have we had that? All right, questions? Now the next one, when you see numbers in both first and second term spots, here's where you could start getting mildly concerned because you're going to have more work to do. But we still start with Pascal's triangle. Genesis, what are we going to write first on 31?
1, 4, 6, 4, 1.
There we go. Then it's not an x, class, it is a 2x that we need to start out to the 4th power. Now you don't have to write 2x to the 4th necessarily. You could write, for instance, class 16x to the 4th, but make sure you raise the 2 to the 4th with the x. Don't just raise the x. The 2 and the x are to the 4th. So my suggestion, I think we can do it in our head as 16x to the 4th, but don't forget the 2. So then both the 2 and the x are cubed, class. 8x cubed. Thank you, Brandon. Class, the 2 and x are squared. 4x squared. Then it's just 2 and x. 2x. And then they are gone. Then we come to my 3y. The 3y starts out gone. Then both 3 and y are to the first, which is just 3y. Then they're both squared. 9y squared. And then they're both cubed. 27y cubed. And then finally to the 4th. What about my signs in this problem, Genesis?
They're just saying.
They're saying they're all going to be positives, yes. So nothing to worry about with those. And then it's just a matter of multiplying. End up getting a 16x to the 4th plus, I think that's a 96x cubed y, plus a 216x squared y squared, plus another 216? 216xy cubed, plus the 81y to the 4th. How many had this answer? All right, sounded like we got a lot of mm-hms, which is a good sign. All right, and then looking at the last one, we have the 5x negative 2 quantity cubed. Again, that's going to be 1331, 125x cubed, 25x squared, 5x, gone. Gone, 2, 4, 8, and then alternate your signs. What's your final answer on 32, Audrey?
125x cubed minus 150x squared plus 60x minus 8.
Good. 125x cubed minus 150x squared plus 60x negative 8. How many got that right? Questions at all on Pascal's triangle, raising to powers? All right, then for 33 through 36, the last half of the homework, the binomial formula. What is that formula? Brandon?
NCR times...
Close. Help in class.
Oh.
R minus 1. So it's NCR minus 1, where R is the number of the term we're finding. We're going to do R minus 1 for my second value. Keep going, Brandon.
A to the N minus R plus 1
Okay.
times B to the N minus R. No, R minus 1 times.
R minus 1. All right, so there's the formula. Make sure that's in your notes. Make sure you're ready to go with that tomorrow on the test. Okay, it'd be a real shame if we didn't know the formula tomorrow. Yes?
Does it matter whether the exponents are in the parentheses?
No, I mean, putting them outside the parentheses has the same net effect. Yep, that's fine. Good question. All right, so on number 33, it says to find the 7th term of 7x plus 6y to the 9th. The first thing we want to do is to identify what is n, what is r. And on this problem, Abby, what is n, what is r?
N is 9 and R 7.
All right, so we're going to start with a combination class of 9 take 6. Combination of 9 take 6, whatever that comes out to. My a in this particular problem class is 7x. That's going to be raised to the n minus r plus 1. Well, n minus r plus 1, 3. Or you could just subtract those two numbers, and you'll get the exponent. Then we're going to raise the b, which happens to be a positive 6y. Here's the case where we do need to think about the sign, especially if it's a negative. Positive, whatever. We're going to raise it to the r minus 1, which is this second number here. All right, so combination of 9 takes 6 comes to a really big number. And not that I don't believe him, but in fact checking, 84 is right. The 7x when we cube it, again, it's not just the x being cubed, it's the 7 being cubed as well, class. 343x cubed, and then the 6 to the 6th, and the y to the 6th.
46,656.
This is just awful. Whose idea was this? So a 46,656 y to the 6th, all of that gets multiplied together. The big number that's on the calculator times the 343 times the 84. Holy moly, I got a billion? 344,252,672. Don't forget about your x cubed and your y to the 6th. And how many have that big ghastly answer? All right, questions on big ghastly answer. Why? It's a great question. I don't have an answer, but it was actually 6y. Number 34. I don't know. It was an effort. All right. 3x plus 4 being raised to the 6th power, and they wanted the 6th term. All right. Starting off, what's n, class?
6.
What's r?
6.
Also 6. We're going to take a combination of 6 take... Oh, sorry, yes. 5, thank you. Brain freeze for a second there. All right, then we're going to take our a term, which class our a is the 3x, and we're going to raise it to the first power. That's easy enough. Then we're going to take our positive 4, we'll just say 4 for now, raise it to the r minus 1, which is the 5th power. So really, the 6c5, that just comes to a 6, I believe. And then we got a 3x, and then the real issue is the 4 to the 5th. 1024. We'll multiply that by the x, the 3, and the 6, and we end up with
18,432x.
And how many had that? For number 34. Questions on 34. All right, number 35, we had a 4 minus y raised to the 13th power. They wanted the 8th term. Let's see here. Audrey, what's n?
13.
What's r? 8. So we're going to take a combination of 13 takes 7. We're going to start with our a term, Brandon, which is 4. We're going to raise it to the 6th power. Then we're going to take our b, Abby, which is
negative y.
the negative y. Here we've got to pay attention to that negative, and we're going to raise it to the 7th power. Negative to an odd power class. Negative. I know my answer is going to come out negative. So Genesis, real quick on the calculator, 13c7. Good, 1716. Then the 4 to the 6th, Genesis. All right, 4 to the 6th. 4096. And obviously, negative y to the 7th power class is negative y to the 7th. Again, that negative does not fall off. We just got to multiply the two big numbers together and end up with what is it, 7,028,736, but don't lose that negative. Slide that out to the front. Negative 7,028,736. Y to the 7th. How many have that answer? For number 35. Questions? All right. What about number 36? Maddie, what was your answer? Really big one.
740,978.
And there's an x in there as well. X, y to the 8th? Yeah, because you had a 2x. There's your a to the n minus r plus 1. So 774,840,978 x, y to the 8th is correct. Questions on any of that? Any questions on permutation, combination, as far as just plugging it in straight up? We're going to look at some word problems here in a second. Any questions on Pascal's triangle, an expansion, or binomial formula? Feel like we're going to be able to do this tomorrow on the test? Yes, no, shake, rattle. All right. Well, let's go and quickly review some things then. I kind of alluded to it already, but if we have an assortment of items and we're going to choose a certain number of them to use, and we're not going to reuse values, and the order doesn't really matter. Class, I am describing a combination. If we've got a certain number of values and I can reuse them, and I'm going to use a certain number of them, then we're talking about just basic counting. What if I've got a certain number of items and I'm going to pick a certain number of them, can't reuse them, and the order doesn't matter? Combination again. What if the order does matter? Permutation. I was just making sure you're paying attention. All right, let's take a look at some word problems then very quickly here. And give it just a minute to warm up here. The awesome junior class has 10 events for elementary students to enjoy at field day. Student has enough tickets left to do 4 activities. How many different ways could he use his tickets, number 1, if he's willing to do the same activity more than once? Just answer the first question for me there at your seats. He's willing to do the same activity more than once. How many different ways can he use his tickets? When you see more than once, class, you know we're going to do what? just basic counting, just multiplying, right? Now here's the question. Is it 10 times 4, or is it 10 times 10 times 10 times 10? Ten times 10 times 10 times 10. Because the first activity he's going to do, there's 10 things he could choose from, right? Then he's going to do another activity. He still has 10 to choose from because he's willing to redo the same activity more than once. Then the next activity, there's still 10 to choose from. And on the final activity, he still has 10 to choose from. Does that make sense? So 10 times 10 times 10 times 10. If he had 10 events and there were 4 snacks, and he was going to choose one of those, 10 events or 4 snacks, and he's going to choose one thing to spend the last ticket on, that's where you do 10 times 4. Does that make sense? Do you see the difference? All right, let's go to the second one. What if he wants to do 4 different activities? So he's got, there's 10 activities out there. I want to do 4 different ones. At your seats, how many different possibilities exist? Ten events. He can do 4 of them. He wants them all to be different. He doesn't want to reuse a value or repeat a value. What do I need to use here, class? Here's a combination, right? There's 10 activities, right? He's going to do 4 of them. Doesn't really matter what order he's doing them in necessarily. Doesn't at least seem to indicate that. So just a combination of 10 events, and he's going to choose 4. And so how many ways could he spend his tickets, class? 210 different ways, 210 different combinations, if you will, of 4 activities he could choose from. How many have that? Look at the last part. What if he wants to do 4 different activities, but to him, the order matters, meaning his very favoritist Everest wants to be last, okay? So the order matters, and he's going to get like, I'm going to do 4 activities. The one I'm like, yeah, okay. Then, oh, I really like this, and then, wow, I'm really going to enjoy this, and this is my favoritist ever. Okay, so if the order matters to him, now what are we going to do, class? It's the same thing, but a permutation now, because the order suddenly now matters. So he may be doing the same 4 events, but if he does them in a different order, that changes the number of possibilities. So, class, 5,040 different ways. So our answer to the first one was 10,000 different ways he could spend tickets if he was willing to repeat. 10 to the 4th, 10 times 10 times 10 times 10 times 10. 210 if he's not going to repeat. 5,040 if he's not going to repeat, and order matters. Do we kind of see a breakdown of all 3 in this one problem? Questions on this? Does this help, I hope, to clarify? I came up with this special for this class. I've never used this problem. It's an original I came up with to try to help you guys understand questions. Let's do another one. Senior snack cart next year, hint, hint, will sell lunches on Thursdays. Students can choose pizza, chicken tenders, or hot dogs. Students who order lunch will also get a bag of chips, Doritos, Lay's, or Cheetos, and they'll be able to pick 1 candy bar as a dessert. Hint, hint. If the snack cart has 6 choices of candy bars, how many different lunches will they sell at your seats? Just a moment at your seats. Do you notice it doesn't say there's 12 items and you're going to choose 2 of them? It lists groupings of items. So here it can't be a combination or a permutation. Does that make sense? It's got to just be a straight counting play. How many main entrees are there? 3. How many different kinds of chips are listed? 3. And then it mentions that there are 6 candy bars. It doesn't mention anything about a drink. I guess they're on their own with that. So we're just multiplying. In class we get 54 different lunches that could be sold. Does that make sense? Questions on this one? Again, you're not picking a certain number out of whatever. So that's always going to be that. All right, there's another one. Bicycle combination lock uses a 4-digit code. Digits are numbers 0 through 9. How many different lock combinations could be created, number 1, if digits can be reused, and number 2, if digits cannot be reused? I think it goes without saying, by the way, that order matters on a combination lock. So even though it doesn't say order matters, as 10th, 11th, and 12th graders, we should know order matters. Right? At your seats. Do number 1 and number 2. do the two problems that are on the screen. Digits can be reused. What do we do? Digits can be reused, repeated. If values can be repeated, that's just straight multiplication. If you can reuse, we've got 10 digits, and I'm going to reuse I can reuse all 10 4 different times. That's all we're doing if things can be reused. Class, so 10,000 different combinations. Now, if you cannot reuse values, okay, part number 2, now we're talking about a permutation, because the order definitely matters, right? So we've got 10 digits, but we're going to choose 4 of them. And since the order matters, we end up with how much? 9,004? 5,040. I can't hear. 5,040 different combinations if you don't reuse a digit on the combination lock. Questions on this one? See the difference. Okay? How about this? Large high school, 42 guys try out for a basketball team, but only 12 of them can be picked for the varsity team. How many different varsity rosters could be created? Are we going to multiply 42 times 12, class? No, definitely not, okay? We don't have 42 of this and 12 of that we're multiplying. Okay, we're taking 12 of the 42. It's either combination or permutation. Which one? Does the order matter? Oh, then if the order doesn't matter, combination. Doesn't really matter which order these 12 people are picked for the basketball team, which is they're on the team or they're not. So let's go combination of 42 take 12. Does that make sense? Got a lot of logical thought going into these, and holy moly, that's a lot of different rosters. I've got it in scientific notation. Did you get that as well? Okay, I wasn't sure if I typed something in wrong. So our number is 1.105 blah, blah, blah. Okay, give me just a few digits. Times 10 to the 10th power. And yeah, lovely. All right, questions on this? Do you see why it's a combination, not a permutation? Senior class of a small high school has only 9 seniors. They'll elect 4 officers, a president, a vice president, a treasurer, and a secretary. How many different ways could officers be elected? Am I multiplying 9 times 4, class? No, because I'm not taking 9 of these and 4 of these. There's a group of 9, I'm taking 4. So it's either combination or permutation. Which one? Order matters, doesn't it? Being the president is a lot different than being stuck as secretary, okay? So this is a permutation of 9 take 4. And we end up with 3,024 different officer selections that could be made. All right, questions on this? It is similar to problems you'll see tomorrow. Questions? All right. Brewster's Real Ice Cream offers 24 flavors of ice cream each day. Customer can enjoy ice cream in either a waffle cone, cake cone, sugar cone, or dish. How many different ways does Brewster's serve ice cream, not counting number of scoops? There's 24 flavors and I'm choosing a certain number of them, class? No, there's 24 flavors and I'm going to pick 1. And there's 4 different ways to get your ice cream and I'm going to pick 1. So this is just counting. We just multiply 24 times 4 and we get 96. All right, what I'm going to encourage you to do is if you felt a little iffy right now, go back tonight, watch the video, but as soon as you see a new problem pop up on the screen, pause it to shut me up, work it out yourself, and then play the video back and see if you did it right. Does that make sense? All right, let's move on. I think this was the last one. I think I ended on ice cream. Yeah, I like ending with ice cream. All right, let's go ahead and review quickly over probability. It was on that quiz we went over earlier before we started the video. Rules of probability. Probability has to be between 0 and 1. If you have an and situation, you're going to take the probability of this and this happening, multiply. This or this happening, add. If it's an or, you have to think to yourself, Are these two things, these two possibilities, I'm choosing this or that, are they mutually exclusive? If they are, you just roll with it. If they're not, you have to remember to subtract that overlap. If you have an and situation, this happening and this, you have to ask yourself, are these two different things dependent or independent? If they're independent, you just straight up multiply. We're good. If they're dependent, that second ratio and then maybe a third ratio has to be adjusted to reflect that this has already been chosen. Does that make sense? All right. Let's look at page 548. Page 548 in your textbooks very quickly. Number 3 and number 4 on page 548. Number 3, number 4 on page 548. Are those valid probability groups? Why or why not? Look at number 3 for just a second. What's our verdict on number 3? Are those valid probabilities, class? No. Why not? Oh, they don't add up to 1. Remember, all probabilities must add up to 1. Okay. The individual probabilities looked fine. It's just they have to add up to 1 in a set. What about number 4? That was a quick no. Why not? One's negative. There's no such thing as negative probability. The smallest probability, class, is 0. And 0 means impossible. 1 means certain. Anything between 0 and 1 is possible. 1 is definite. 0 is impossible. Anything in between is possible, though normally over 50% we call it probable. Anyway, I digress. Jump down to number 7 and 8. Number 7 and 8. Certain newspapers had at least 15 automobile advertisements 35 of the past 48 days. What's the probability that the newspaper will have at least 15 automobile advertisements on any random day? And then what's the complement of that? It says 3 decimal places, or 0.1% is how we do it. $35 of the last 48 days, they've had a whole bunch of ads. What's the odds that they have a whole bunch of ads again? And what's the complement of that? What's the probability you will have at least 15 ads, class? 72.9%. Okay, what's the odds that you don't have at least 15 ads?
27.1%.
How do we get the second answer? Yeah, 1 minus that. Or, I like the shortcut, make this a negative and add 1. It's the same process, it's just quicker. All right, so this is the chances it will, that's the chances it won't. We call this, class, the complement. All right, look at number 8. Sarah took her umbrella to work 32 of the past 73 days. It rained 33 of the past 73. Anyway, what is the probability she will bring her umbrella to work? And then what's the complement? 32 of the past 73 days she took her umbrella. What's the probability on a random given day she'll bring her umbrella? And then what's the complement? All right, what's the probability she brings the umbrella, class? 43.8%. What's the probability she doesn't? 56.2%. We just subtract from 1. Questions on 7 and 8. Do you see that 7 and 8 are both based on past history? What do we call that? Relative frequency. The relative frequency of running 15 ads is 72.9%. The complement, 27.1%. The relative frequency of bringing umbrella, 43.8%. The complement, 56.2%. Does that make sense? Look at numbers 11 and 12 on the next page. Emily has to pick a number between 1 and 10. What's the probability she picks a 3 or an odd number? When anytime we see or, class, we got to add. What's the probability of a 3? 1 to 10. What's the probability of an odd number? 5 to 10. 1, 3, 5, 7, 9 are all odd numbers. When it says or, we add. Is there any overlap between 3 and odd? How many odd numbers are also 3? 1 and 3. Kind of stupid way to look at it, right? Or you could just say, well, 1 is odd, so forget this, and we just end up with a 5 to 10 or 50% chance, 1 to 2. Let's see, look at number 12. Look at number 12. Latasha chose a card from 6 cards labeled 1 to 6. Letter B, what's the possibility, we're looking just at 12B, that a prime number or a multiple of 3 will be chosen? What are the prime numbers on those 6 cards? 2 is prime, 3, 5. So how many prime numbers? 3 out of 6. All right, how many multiples of 3 on those cards? 2. What are they? 3 and 6 are your multiples of 3. And again, it said or, so we're going to add, are there any numbers that are both prime and multiples of 3? Which one? The 3, right? So there's one that is an overlap. We'll subtract that to get 4 to 6. Yeah, there we go. Reduces to 2 to 3. We say 66.7% chance, but 2 to 3. Questions on the or stuff. And watch for mutual exclusivity, or worse yet, not. If not mutually exclusive, we've got to subtract that overlap. Drop down to number 14. Jackson has a lot of hats. 5 red, 3 blue, 7 brown, and 12 multicolored hats. Anyway, probability of the red hat and the blue hat will be chosen in that order with replacement. First thing you're going to have to find. How many hats, class? 27 hats. Okay, so probability of red. 5 to 27. He says with replacement, so he chooses another hat out of the mix, and it's a blue one. What are the odds? 3 to 27. Again, all 27 hats still available. We multiply, we turn it into a decimal, we get very low odds.
49.7%.
Ooh.
2.1%.
I got 2.1%. Did you add or did you multiply?
I added.
Oh, okay, and, so multiply. That's what happened. So 5 27s times 3 27s gives 729. And then you divide it to get a decimal. 0.021 is what it rounds to at least. All right, what about blue hat, then brown hat with replacement? Blue hat, then brown hat. Class, what's the probability of blue? 3 to 27. What's the probability of brown? 7 to still 27, right? Because we replaced, so we end up getting, let's see, it's 21 to 7, 29, whatever that comes out to. You said 2.9%? That's what I got as well, right? Questions on that? Drop down to number 16 as we round out the hour here. Nicholas has a bag of balloons that haven't been blown up yet. There are 30, that's good. If you're choosing a pre-blown up balloon, it's either not fitting in a bag or it's already slimy from someone else's. Anyway, 13 red, 16 blue, 15 green, 21 yellow. I should stop thinking into these problems so much. Letter A, what's the probability of yellow balloon and then a red balloon in that order without replacement? What's the probability of, well, first of all, how many balloons? 65? Hold on, I'm not there yet. You like 65? You do? Yeah, I do too now. All right, 65, not that I doubt you, Abby. 65 balloons, what's the probability of yellow balloon? 21 to 65. And then, without putting the yellow balloon back, as you blow it up and set it aside, what's the probability of a red balloon? 13 to
20. Oh, I meant 64.
64% chance. We're going to multiply those, and you're going to get yourself a decimal. 6.6% chance. 6.6% chance. Notice dependent because we had to adjust for the choice. And we'll have to wrap up there. There's plenty of practice on pages 548 to 549. I'll do this for you. If you want to work more of them and have me check them before school tomorrow, or if you're watching on YouTube, send me the work. I'll check it for you and go over it with you. But there is no written homework. You do what you need to. Maybe it's working on those 2 pages. Maybe it's rewatching a video. Maybe it's just going through and studying your notes. You do what you need to be ready for the test tomorrow over sections 10.6 to 11.2. Have a wonderful rest of your day, and you are dismissed.